Hello everyone. So we are working on a project for smart door unlocking system. The main objective of our system is to provide immense security to the users. We can see that the working sector of India is increasing at a high rate. In such an era, having highly secured entrance system is a basic necessity. Along with the security, we also aim to provide fast and non-invasive systems for identity verification. Also, the current situation of pandemic made us realize that the need of touch-free system is at a peak. We thus aim to fulfill this need too. Now passing to Niket, he'll explain the relevance of this project to the subject DCN.
So I'll be talking to you about the relevance of this project with respect to the subject that we are studying, data communication network. Now, in this subject, we have studied about the various communication protocols, and we'll be implementing one of them, which is the Wi-Fi module. Now, Wi-Fi communication is basically a part of the data link layer, and we'll be using the ESP8266 Wi-Fi module along with an Arduino. The Arduino circuit is the one which will control the door, and in order to communicate with a computer vision algorithm, that is a machine learning algorithm, which will be used to recognize the face of the user and to verify whether the person trying to open the door is the correct person or not. We'll be communicating between these two modules, which is one is the Arduino module and one is the machine learning module. We'll be communicating using a cloud platform, which is ThinkSpeak. Now, ThinkSpeak is a platform provided by MathWorks, and we'll basically be using the right API from the machine learning algorithm. So once we detect a face and we get a result whether this person is a valid user or not, we'll get this result and we'll post it on the channel of ThinkSpeak using the right API, and we'll get this information using the read API from the Arduino, and the communication between the Arduino and ThinkSpeak will occur using this Wi-Fi module. Now, the ESP8266 Wi-Fi module is a self-contained SoC with an integrated TCP/IP protocol stack that can give any microcontroller access to a Wi-Fi network. Now, this communication is a part of the link layer in TCP/IP protocol, as I mentioned earlier. And in the OSI model, it can be considered to be a combination of the data link layer and physical layers. And I'll now be explaining the flowchart of this project. So how exactly it functions. So initially the system is started, and we'll ask the user whether they want to register a new face. So in case there are no faces registered, we'll obviously ask them whether they want to register any faces. And if there's already a face, they'll have an option for no. And once they've selected the option, if they select yes, then we'll be scanning the new image of the person, of the valid user. And after that is completed, the registration part is completed, we'll be scanning the person's face who's trying to unlock the door. And then we'll check whether this face is a valid one or not. And if the response is positive, it will be this response will be communicated to the Arduino circuit. Now, if the response is positive, the door will be opened, and we'll be having an LCD which will print a message welcoming the user. And if the response is negative, then we'll be sounding the buzzer. Moving on, the next part of the machine learning algorithm will be explained by my friend Ayush.
So thank you, Niket. So now we're moving to the defining the machine learning algorithm and how it works. So first of all, actually we're using Google Colab. Okay, Google Colab, actually why we're using it? Because Google Colab have many embedded software inside it. You just have to call the application and use it in your code in order to get a perfect result. So as you can see, we have installed different application, which is Keras face application, Keras application, in order to sense the face and provide the output. We'll use some different libraries, which is NumPy and Matplotlib and TensorFlow. Now moving on to the part of the code. So here actually, the code is divided into basically three parts. The first part of the code is where the user has to take a photo, and what the photo, this algorithm, what will it do? It will scan the photo and it will enhance the photo in 16x16 megapixels, small square blocks, in order to just get a clear picture about the person who is coming at the door. So now you can see here, you can see the canvas and different URL. So just for what? You'll just scan the photo, okay, take each block, enhance each block, and feed it in a system. Now moving on to the second part of the code, okay. So like if some person is in hurry, so here first of all, Ishika will register a photo just for basic enhancing and basic registering her. Now moving on to the second part of the code photo is like if a user is hurry, okay, like we are rush back from office to home and rush back again back to the office. So like if a person is coming and is showing just only his left or right face, okay, and the photo feed of the person in the system is a full face recognition. So what the software helps, it takes the half side of the face photo and using different machine learning algorithms, it with help of datagram points, it actually binds and makes a complete photo in order to check that the person who has come and asked for opening the door is a real person or the same or real person or not. Okay. Now moving to the most important part of the code is the third part of the code. What is that? Actually, it's an datagram algorithm. It's also a datagram algorithm. This algorithm, what it does is actually takes a snapshot of a photo, okay, and divides each of the photo in different measurements. Okay, there are 128 different measurements of the of your photo, which is used to compare the person who has come to open a door. Okay, if a registered face has different measurements, and the person who has come to open a door have different measurements, the door will not open. Okay. How this application work? We'll see the running. We'll see it running over here. So now moving on, this part, which as my friend told you about the ThinkSpeak IoT cloud. As my friend told you about ThinkSpeak IoT cloud, where you have to use the read and write API key. So here we'll use the read API key in order to get the result from here and give the output of the result onto the Tinkercad link. So we'll use the write API key over here. Now Ishika, my friend, will register her face in order that she is the owner of the room or cupboard, anything you can say. Now you can see she is registering the photo. It might take some time depending upon your net speed or your speed of the CPU. Now Ishika's face has been registered in the system. Now the person will come to the approach to the door, will scan his or her face in order to get allowance in order to enter the or open the door. If the person who's asked to open a door is the right person who owns the cupboard, then her name along with the API key will be printed over here. Now moving on to Ashutosh, which will tell you how the output in the Tinkercad works.
Yes, thank you, Ayush. So now this is the best part of the project where you can see the demo. So first, actually she scanned her face. Now she is going to update it in the cloud. And via Wi-Fi module, she is going to transfer the data onto our circuitry. So moving on to Tinkercad. So yes. So it will take some time. Yeah, so since she is the correct owner of the cupboard, so hello Ishika is being printed. So now moving on to the code. Yes, so this is the Arduino code. So we have the liquid crystal library and for LCD display. Then we have the ThinkSpeak setup. Actually, we have to first set up the ESP8266 Wi-Fi module. So these are some basic syntaxes that you need to go through before working on this. So it's all fixed actually. There are some serial communication baud rate is there for communication. So with the Wi-Fi module and with the cloud. So next there's a function any data that is going to fetch the data. So yeah, so if you scroll down, you can see all those things. Can we go down? Yeah, so here we have the actual working. So this is where we will be seeing the actual implementation that we are scanning the proper face, or this is just the if else loop part of that. We also have a buzzer in after this code, we'll be showing a demo of a wrong person trying to do a security breach. This is the loop which will be running continuously. 328, sorry. So now we'll be showing a demo of a wrong person trying to access our system. So now once again we'll rerun the same process. So now just we'll be scanning a different person. So he's an intruder basically. Yeah, now the face is captured. So now we have to go to the ThinkSpeak cloud. Yeah, we have to update here, refresh it. Now it will give data back to our circuitry. Yes, so it's taking some time. So buzzer will turn on actually. I think the net problem is there. Yeah, so it's printing access denied and the buzzer sounds. So there's a small motor there connected over there, which I forgot to mention previously. So this is the door, which we are taking the prototype of a door just like that. So it's showing 0 RPM, it's not rotating. In previous case, while it was the perfect access, it was rotating. So this was all about our project. So thank you everyone.